Welcome to the video in Chapter 6, more about triangles, Lesson 4 specifically about right triangles. How do we test right triangles for congruence? So a quick review here about testing for congruence. This goes back to Chapter 5 about side, 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 angle, angle, and angle, angle, side. So we're going to learn how we can specifically apply those sorts of tests to determine if there are two right triangles that happen to be congruent. Though there are three sides to every triangle, a right triangle really only has two names for these three sides. The hypotenuse is the side that is opposite the right angle, and we have done this before where we talked about being opposite of an angle. The right angle is here. The hypotenuse is the side opposite of that. It's always going to be the longest side. The legs are the two sides that form the right angle, and they're not always congruent. So just because we use the same name, the same word to describe them, they are each a leg, they do not have to be the same length. So the 90 degrees is here, created from the two legs, and the hypotenuse is opposite of that. And as we move into the test, the theorems about the congruences of right triangles are just special cases to those previous theorems that I've already mentioned. And the names of the theorems stem from the tick marks. So that's what we're really going to be looking at. We have to check to see what information is already given to us about their congruency. There are four tests that we can use with right triangles. And the first one that we're going to look at is the Ll Theorem. And this stands for leg. This is similar to the side angle side. It is the side angle side, but specifically with right triangles, we don't have to mark the right triangle, that right angle there as congruent because they are right angles. But we just need the two legs to be congruent. So if the two legs of a right triangle are congruent, the corresponding ones, like they don't have to be congruent to each other, they have to be congruent from one triangle to the next triangle, then the two right triangles are congruent, and you could say by the Ll theorem. Second would be the Ha theorem, which stands for the hypotenuse and one of the acute angles. So we need more than just that right angle there, so that's why that focuses on the acute angle. But if you have the hypotenuse and one of the acute angles congruent, that's all you need to say that the two right triangles are congruent. Third is the La theorem. This is the leg angle, but focusing again on the acute angle, it's just simply not, can't be that right angle. So a leg angle congruency relationship is the La theorem. And as long as the angles are in the corresponding location that they're matching, so right angle, one tick mark, and then there's the angle that is marked. You can use the leg angle theorem. So the last one is the Hl postulate, and this is a postulate simply because it applies to the right angles only. And we're going to talk about this here. If you remember back from Chapter 5, we said that there was one specific relationship that is not allowed to be used with triangle congruence, one specific test, and that is the ASS, the angle side, and that is not allowed to be used in anything except right angles. Because if you look at the hypotenuse leg, the hypotenuse and the leg and the angle would be the right angle there. So there's that ASS, angle side, angle side. This only works in the right triangles to have the hypotenuse and the leg, simply because we do have that other angle, but as long as they are the congruent ones, and actually you can't really see this purple extra tick mark there, that's why this only applies to right triangles, is the hypotenuse leg postulate. And we don't have to be real particular about theorem versus postulate. I'm just going to ask you to write the actual relationship, La or HL, for example, but we just want to realize that this only applies to the right angles. So let's go through some practice problem, writing a congruence statement, which remember is triangle ABC is congruent to triangle XYZ by one of these four tests. If they are not congruent at all, then we will write not possible or not congruent, whichever works. So let's look at the information that is labeled for us. We are obviously dealing with the right triangles because there are the right angles. And if we look, there's the hypotenuse that is marked congruent, and that is the hypotenuse because it is opposite of the right angle. And then the other side that is marked as congruent is a leg. So we have the hypotenuse and a leg. And so we can say by and actually let's just go ahead. Let's just write the triangle congruent statement because this is the Hl postulate. So we're gonna say triangle ABC is congruent to triangle. Now this is where we have to be careful about order. A, B, C. So I'm starting opposite, or I'm not starting at the right angle and I'm going down the single tick mark side. So in this triangle, I need to start at E. So triangle ABC is congruent to triangle EFD. So again, ABC is congruent to EFD, and we're gonna say by HL, so by the hypotenuse leg. In this problem, again, we're just going to mark what we have here. This is a leg because it is not the hypotenuse, and if it helps to actually label where the hypotenuse is, you can do that. That's the side, again, opposite the 90 degrees. It's always that longest side. So the single tick mark is a leg. The double tick mark is also a leg. So that we can use the leg theorem. So I'm gonna say that triangle AJK is congruent to triangle NGW. We'll say by LL. Now, again, I'm going to focus a little bit on the order of my letters here. I don't like to start with my right angle because I like to very clearly know where that one is and which direction I'm going. So I always pick one of the other vertices to start with. So A is the one that connects with the right angle with the 2 tick marks. So A, 2 tick marks, J, and then K. So the one on this triangle that connects to the right angle with the 2 tick marks is N. So N, 2 tick marks, right angle at the G, and then W. So A, J, K, N, G, W. So in this problem, I have a leg that is marked congruent. And again, it's not the hypotenuse because that is the side opposite the 90 degrees. Other than that the only leg that is marked congruent, I do have this acute angle here. So we have an angle, and I'm not worried about including the word acute. Like I'm not gonna say leg acute angle, it's just leg angle, but we just need to understand that it needs to be one of those non-right angles. So that is enough for us. The LA is a test that works. So we're gonna say triangle FRE is congruent to triangle PLI. So again, started with that acute angle, that congruent angle. So F down to the right angle and then out. So FRE, so I'm gonna start at the single, that congruent to the right angle and then out, so PLI. And to finish it off, we'll say by leg angle. Final problem here. It looks like we have a side that's marked, and the question is, well, what is it, a leg or is it a hypotenuse? And because of its relationship with being across or opposite that 90 degrees, this is the hypotenuse. And we have to understand that this is also 90 because that creates a line right there. So that means that this side is also the hypotenuse. So the green single tick mark there is a hypotenuse. And then the only choice is an acute angle or a leg. Those are the only ones that are left as far as using the hypotenuse. And I don't have any angles marked here. And though it might look like this could be an angle bisector, we don't know for sure. So the only other thing we actually do have is this side OM. Let me grab a different color here. That side OM is in both triangles. It is in OMZ and it is in OMN. So that is congruent to itself in each triangle. If I were to split these two triangles apart, then OM would have to be congruent to OM. So that is a leg. So we do have a hypotenuse leg relationship. So we would say triangle OMZ is congruent to triangle OMN by hypotenuse leg. And this concludes this pretty quick lesson here. So just understand that we're just adding to our lists of tests to use for right triangles. So from the chapter 5 material, we have angle, side, angle. We have angle, angle, side, 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 and side, angle, side. So now we have all of those 4 from previous, as well as these 4 new ones that specifically apply to right triangles only.